Hi, in this chapter, Chapter 9, we're going to be discussing position tolerancing, some expanded principles. Let's start with our objectives. Number 1, to explain functional gauging concepts for checking hole position tolerances that are specified at MMC. Number 2, specify and explain composite position feature control frames or composite feature positional tolerance specifications. Number 3, specify position tolerance for inline holes. Number 4, specify position tolerances to control symmetry. Number 5, specify position tolerances to control coaxial features. And number 6, differentiate between the following definitions of the following terms. Composite positional tolerance, pattern location tolerance, that is the pattern locating tolerance zone framework, and the feature related tolerance, that's the feature relating tolerance zone framework, functional gauging, datum simulators, two-segment feature control frames, coaxial hole patterns, and radial hole patterns. Okay, let's start with talking about what our single line position tolerance is. This is what we did in Chapter 8. We had a single line or a single segment for a positional tolerance here. Now this creates a tolerance zone framework. You'll see these acronym in the future here, TZF, tolerance zone framework, consisting of the basic locations of the controlled features relative to the reference datums. In your textbook, in page 333, it explains that the tolerance zone framework is made up of the basic locations of the controlled features relative to one another and relative to the reference datums. So the tolerance zone framework consists of the datums and the basic dimensions that locate the holes that are used in the positional tolerance. So that is what a tolerance zone framework is. A composite position tolerance is they provide the designer more flexibility than just this fixed single line position tolerance. So let's talk about composite position tolerances. Okay, in a composite position tolerance, we have a single geometric characteristic here and two segments. Okay, so the feature control frame contains one position tolerance symbol and two or more segments. The first segment is called the pattern locating tolerance, and the lower segment is referred to as the feature related tolerance. Okay, so the datum feature references are typically in the same order with the first segment, with the same modifiers, and we're going to be talking about the datums over here on the second line in a bit here. So let's talk about the pattern locating tolerance zone framework. This is established by the first or the upper segment of the feature control frame, and it really has the same effect as a single segment position tolerance specification like we discussed in Chapter 8. The basic dimensions will give the true positions within the framework. That would be the true positions from the referenced datums. And it's constrained in translation and rotation relative to all of the referenced datums. So that's what that means. It's pretty much just what we talked about in Chapter 8 with the single line feature control frame. That is the pattern locating tolerance zone framework, and this describes what that means. Next we'll talk about the feature relating tolerance zone framework. It's established by the second segment of the composite position tolerance. It affects the location of features relative to one another. And there's basic dimensions within the framework, and it has the same pattern location tolerance zone framework with regard to the true positions between the features. Okay, so some of the same dimensions here that establish the tolerance zone framework for the pattern related are the same basic dimensions that establish the locations for the feature relating tolerance zone framework. And if you notice here, this is only constrained to datum A here in the second feature control frame. So really what we're doing is we're controlling these pattern of holes once they're located with respect to one another. Let's take a bigger peek at this same example. Okay, so here would be our orthographic representation of our holes. We have this composite positional tolerance, 35 thousandths at MMC, true position, relative to datums A, B, and C. And then that's the pattern locating tolerance zone framework, and that's what we're shown right here. We have the three datums drawn in here conceptually. We have the locations from the tolerance zone framework shown in here, and we are holding these holes to a 35 thousandths diametral tolerance zone at MMC. Okay, so now over here, once we're within the pattern, okay, we can hold our tolerances tighter. So typically when we do composite tolerances, the second one, the feature relating tolerance zone framework, will usually always be smaller than the tolerance for the pattern locating tolerance zone framework. And I want you to think about it this way. If you had like a big panel, okay, and it was holding these different instruments in the panels, like you had different meters and stuff installed in a pattern. Okay, so and then there was a 4-hole pattern that located a particular meter in that pattern. So you really don't care where the 4 holes are for that meter. I mean, you can kind of float that meter anywhere you want within the panel. But once you locate one of these holes in that pattern, you're going to want the rest of the holes to be held a little bit tighter to that, so you'll be able to mount this meter in the panel. I mean, so whereas you don't really care exactly, you don't really care as much exactly where the meter shows up in the panel, you want all the holes to line up for that meter. So in which case we can refine the position once we're in the pattern with our feature related tolerance zone framework. We can make this a little bit tighter to make sure that all of our holes line up with our meter that's being installed in this panel. So this is a way of controlling our holes further. It gives the designer more flexibility in assigning tolerances on his parts, or his or her parts. I'm going to talk about the effects of using datum feature references in the feature related tolerance zone framework. So the second line, the feature related tolerance zone framework, we have these 4 conditions here. We have, first of all, no repeated datums. In this case, we repeated just the primary datum, and in this case, we repeated the primary and secondary datum feature references. What does all of this mean? Okay, let's talk about the first one. No repeated references. Okay, so we must meet the tolerance requirements of both of those segments. The feature-related tolerance zone framework is not constrained in translation or rotation. And what that means is there is no control of our holes here in its orientation with respect to datum A. There can be some rotation here in translation. So if you notice, our tolerance zones here are not necessarily, you know, square, because we didn't use that datum A. So that's what that means, and it's typically, we really wouldn't do that generally in reality. I think what we would do is probably more related to like this, where we're using one datum in the feature related tolerance zone framework. We're using one datum, and what that does, it allows us to square up our holes relative to datum A. So that's really what that means, and to me this is more practical than the previous example of, and I'll show you this one, of not using the datum A here. So when you're not controlling the feature relating tolerance zone framework to datum A, you know, that can cause you some issues with the rotation of this part in here. So again, This is a little bit more common, where we're using datum A here, and that allows us to square up our holes. Now, here's what happens if we use the two datum references in here. And I think I want to stop this movie here so I can keep these movies short. Thank you.